Article 450.21 of the National Electrical Code addresses the installation of transformers exceeding 600 volts nominal. It stipulates that these transformers must be installed either in a vault constructed according to Article 450 Part Roman 3 or within a separate transformer room. This room must be built using fire-resistant and heat-insulated barriers. The question revolves around whether applying flame-retardant panel board paint or plywood wool satisfies the requirement of a fire-resistant heat-insulated barrier, specifically when a transformer is placed less than 12 inches from the wall. The answer is no. The panel board paint does not meet the code's definition of a fire-resistant heat-insulated barrier as it pertains to Article 450.21a. Therefore, installing a transformer in such a manner would constitute a violation of this code section. To elaborate further, understanding the intent behind Article 450.21 is crucial. The code aims to minimize the risk of fire and heat-related hazards associated with high-voltage transformers. Transformers, especially those operating at voltages above 600 volts, can generate significant heat during operation and, in the event of a failure, can pose a substantial fire risk. Hence, the requirement for installation within a vault or a dedicated room constructed with specific fire-resistant and heat-insulating materials. These vaults or rooms are designed to contain a fire within the transformer enclosure, preventing it from spreading to surrounding areas and endangering personnel or property. The phrase fire-resistant heat-insulated barriers refers to construction materials and methods that can withstand prolonged exposure to high temperatures and flames without losing structural integrity or allowing excessive heat transfer to the other side. This typically involves the use of materials like concrete, masonry, fire-rated gypsum board, or specialized fire-resistant panels. These materials are tested and rated according to established standards such as those developed by underwriters Laboratories UL or Astom International to determine their fire resistance and heat insulation capabilities. Flame-retardant panel board paint, while it can slow down the spread of flames on a combustible surface like plywood, does not provide the same level of fire resistance and heat insulation as the materials specified for transformer room construction. The paint typically works by releasing flame-inhibiting chemicals when exposed to heat, which can suppress the combustion process. However, it does not prevent the plywood itself from eventually burning or significantly reduce the amount of heat that is transferred through the wall. Therefore, relying solely on flame-retardant paint would not provide adequate protection in the event of a transformer fire. To comply with Article 450.21a, one must either construct a vault according to the specifications in Article 450, Part Roman 3, or build a separate transformer room using materials that meet the definition of fire-resistant and heat-insulated barriers. Article 450, Part Roman 3 outlines detailed requirements for transformer vault construction, including the minimum thickness of walls, roofs, and floors, as well as the fire resistance rating of doors and other openings. These requirements are designed to ensure that the vault can effectively contain a fire for a specified period, allowing time for emergency response and preventing the spread of the fire to adjacent areas. If constructing a separate transformer room, the choice of materials for the walls, roof, and floor is critical. The materials must have a fire resistance rating that is appropriate for the size and voltage of the transformer, as well as the occupancy of the surrounding building. Fire-rated gypsum board, when installed according to the manufacturer's instructions, can provide a significant level of fire protection. Concrete and masonry are also commonly used for transformer room construction due to their inherent fire resistance. In addition to the fire resistance of the walls, roof, and floor, it is also important to consider the fire resistance of any doors, windows, or other openings in the transformer room. These openings must be protected with fire-rated closures that are designed to automatically close in the event of a fire. The closures should also be properly sealed to prevent the passage of smoke and hot gases. Furthermore, proper ventilation is essential for transformer rooms to prevent the buildup of heat and flammable gases. Ventilation openings should be designed to prevent the entry of rain, snow, and debris, and they should be protected with screens or louvers to prevent the entry of birds and animals. It's also important to consider the location of the ventilation openings in relation to other building openings to prevent the spread of fire and smoke. Now, addressing the specific situation of the transformer being less than 12 inches from the plywood wall, this proximity does not inherently violate Article 450.21a, provided that the transformer is installed in a vault or a transformer room that meets the code requirements. The 12-inch spacing mentioned is likely a misunderstanding or a separate requirement related to working clearances or other considerations. The primary concern of Article 450.21 is the fire-resistant and heat-insulating properties of the enclosure surrounding the transformer, not the distance to nearby walls, unless the distance affects the ability of the wall to provide adequate fire protection. However, other sections of the National Electrical Code, such as Article 110.26, address working clearances around electrical equipment. These clearances are intended to provide sufficient space for electricians to safely install, maintain, and operate the equipment. The required clearance distances vary depending on the voltage of the equipment and the presence of exposed live parts. Therefore, it is essential to consult Article 110.26 to ensure that the transformer installation meets the minimum working clearance requirements. In addition to the NEC requirements, local building codes and regulations may also impose additional requirements for transformer installations. It is important to consult with the local authorities having jurisdiction AHJ to ensure that the installation complies with all applicable codes and regulations. The AHJ may have specific requirements for fire resistance ratings, ventilation, and other aspects of the installation. In summary, installing a transformer over 600 volts nominal less than 12 inches from a plywood wall, even if the wall is painted with flame-retardant panel board paint, would be a violation of Article 450.21 of the National Electrical Code. Flame-retardant paint does not meet the code's definition of a fire-resistant heat-insulated barrier. To comply with the code, the transformer must be installed in a vault constructed according to Article 450, Part Roman 3, or in a separate transformer room built with fire-resistant and heat-insulated materials. It is also essential to comply with other applicable codes and regulations, including those related to working clearances and ventilation. Always consult with the local authorities having jurisdiction to ensure that the installation meets all applicable requirements. It is also important to note that even if the transformer is below 600 volts, other sections of the NEC might still apply, particularly concerning working clearances and general installation practices. Proper labeling and signage are also crucial for transformer installations. The transformer should be clearly labeled with its voltage, kVA rating, and other pertinent information. Warning signs should be posted to alert personnel to the presence of high voltage and the potential hazards associated with the equipment. Regular inspections and maintenance are essential for ensuring the safe and reliable operation of transformers. The transformer should be inspected periodically for signs of damage, overheating, or other problems. Any issues should be addressed promptly to prevent equipment failure and potential hazards. Furthermore, it's worthwhile to consider energy efficiency when selecting and installing transformers. High-efficiency transformers can significantly reduce energy losses and lower operating costs. The National Electrical Manufacturers Association (NEMA) has developed standards for transformer efficiency, and it is recommended to choose transformers that meet or exceed these standards. Additionally, consider the load characteristics when selecting a transformer. The transformer should be sized appropriately for the expected load to ensure efficient operation and prevent premature failure. Overloading a transformer can lead to overheating and reduced lifespan, while underloading can result in reduced efficiency. Consulting with a qualified electrical engineer is recommended to determine the appropriate transformer size for a specific application. When working with electrical equipment, it is essential to follow all safety precautions and wear appropriate personal protective equipment (PPE). This includes safety glasses, gloves, and other protective gear as needed. Always de-energize the equipment before performing any work on it, and verify that it is de-energized using a reliable testing device. If you are not qualified to work on electrical equipment, it is best to hire a licensed electrician to perform the work. Electricity can be dangerous, and it is important to take all necessary precautions to prevent accidents. Finally, remember that the National Electrical Code is a living document that is updated regularly to reflect changes in technology and best practices. It is important to stay up to date on the latest code requirements to ensure that electrical installations are safe and compliant. The NEC is available for purchase from the National Fire Protection Association, NFPA, and other sources.